Uh, good, good evening, Chela. How are you? And I think there are a couple of other people that just joined. Now, I'm interested in hearing your thoughts on the talk before, as we're waiting for the others to join us. I don't know if there was anything insightful. I mean, it's an obscure area here. It's not your usual data mining application domain, but I don't know if you were able to follow through with the extraction process, because I told Matilda to especially focus on how she was extracting data. Yes, please. I think Chela, you wanted to say something?
Yes, Doc.
Yes.
Well, I followed the presentation from Matilda. It was interesting. I enjoyed it.
Yep.
But there is one thing I think I did not get at the end of the day.
Yep.
You, it was a talk about is it information repository for institutions. Then I noticed quite a number of institutions do not post their research works, there. So the picture I have is that there is not much importance attached to that. And I joined the presentation about 30 minutes late. So maybe that was talked about, that was discussed and I missed it. So my question is, what's the importance to lecturers in particular to have their work shared or posted on the institutional repository? Maybe on Google Scholar, there is exposure, but with institutional repository, how do they benefit? What impact does it have? Uh, for the institution, maybe students can get to read their works, but as an individual, what do they benefit from that? Thank you.
Right, right. Great question, actually. I had, so I'm going to say a couple of things you mentioned here. Institutions don't post things, no importance attached to that. And then what is the importance? So you see, when I was doing my presentation, I started off by providing a bit of context, right? Things like this, right? You know, apparently Africa produces just 1.1% of the global scientific knowledge. Things like this, these skewed maps. I don't know if you've come across these distorted maps. This particular map shows you it's a rescaled map of Africa relative to the scientific the contribution to scientific knowledge. In other words, publishing. Now you see the part in green here. This is Africa, and in fact you notice that the part of Africa that seems larger is the northern part, right? Sub-Saharan Africa is virtually desolate here. And, the part at the tail end there, that's mostly South Africa. Yeah, yeah, that's the other thing. I mean, it's not so important here, but the thing is, you see, if you are not, so number one reason why this is important, I'm going to go to the direct part, is this. For the individual, right? If I decide to, I'm just going to archive on my website, it's okay, I'll be fine, right? But the problem is that your institution is compromised. Specifically things like the ranking. Now, here's a question to you, right? If, let's say you are not from Zambia, you are from, I don't know, for argument's sake, you're coming from Namibia, and you're looking at universities elsewhere in Africa where you'd want to go to, where do you go? You go to places like this, right? You start ranking the universities. In fact, when you are deciding on which university you are going to do your master's from, probably one of the very first things you are looking at is a reputation. So if you don't archive those things on the repository, the reputation of the institution is compromised. That's the one thing. The other thing is, as an individual, you know that the way academia works, right? I've had people contact me because they came across me online, right? They'll come here. They'll look for, they'll look for light on Pili, right? The reason why, if you look at my profile, the reason why you find all this detailed information, I even have a knowledge card, is because I deliberately curate the things that I publish. That's the one thing. The reason why, right, in this day and age actually, the reason why if you go to ChatGPT and you ask it, tell me about Lighton Piri from the University of Zambia, the reason why this thing is going to come up with things like, oh, Lighton publishes, I don't know if it's going to bring up this, Lighton is a research and publishes this, is because I carefully curate information on UNZA platforms and on my blog, right? I don't know if it's going to have UNZA platforms here, probably doesn't here. But part of this information is coming from my UNZA profiles, right? The other thing is, when people, there's a lot happening in the world, right? Imagine somebody has funding and they're looking for a collaborator from UNZA and they don't know, right, who to collaborate with. Where do you think they're going to go? They will come to an UNZA platform, the website here, right, and search, where is Lighton Piri? They'll go to the repository. What has Lighton Piri published? So if the things that you publish are not documented like this, people will not know that you exist, that you'd be useful to them, But more importantly for me, I think, and this is the part that perhaps I hope my colleagues have thought about this. If you go to, like, let's say Google Scholar and you search for this, just for content coming from Zambia, this is banned, right? I did this fresh search today, right? Where I'm doing a focus search using the site operator here to say, show me publications linked to the ac.zm domain. There are policymakers in the country, not-for-profit organizations that do very important things that rely on things we publish from universities. If those things are not visible, those people will not know, right, that there's work that has been done already. So there's quite a number of reasons here, but chief amongst them are the ones that I just highlighted. Now, the question you asked, institutions don't do this. And by the way, Matilda neglected to mention something here. You see, if you go to the HEA website, right? The HEA website will tell you that Zambia has a total of, last time I counted, maybe there are more now, 123 higher education institutions, universities, 123 of them. I don't know why the HEA website is taking long here to come up here. But there are 123, and if you are paying attention, what Matilda said was that out of the 123, I think she said 11 of them, right, have functional repositories. Now, the argument that could be made is, oh, hey, listen, I mean, some of them are just teaching universities. Okay, that's fine. If you're teaching university, you don't do research. But surely, there's more, right? And we know that there's more, especially those that offer postgraduate training. If you offer master's programs and PhD programs, then you do research. If you're doing research, the question we should be asking you is, where is that research so that we access it? Where is that research so that there's no duplication of effort, right? So that I don't do the same things that you've done already. But the reason why they don't do it, I guess, is for most institutions, the focus is on teaching, really. That's where their money comes from, is from teaching. It's still 123, 108 private and 15 public. So if your focus, if you realize that most of your money comes from teaching, you won't really obsess a lot on research. And in fact, if you sit down and think about, how institutions like UNILAS operate, it's part-time lecturers, right? Most of those people probably come from institutions like UNZA. You can't claim their publications. So as a result, you won't really pay a lot of importance. And also, if your target is Zambia and you're not really thinking about, people potentially coming from outside Zambia, you won't really think long and hard about whether you are number 10,000, right, on the rankings. Is it? Because most of your money comes from Zambians. So I don't know, I hope that helps address some of these questions that you had.
Sure, Doc. Thank you.
Yeah. I've been thinking about this for a very long time, since I came to UNZA. And, sometimes, and I've worked with a number of students. Most students I work with, I force them to do this. I hope that some of them will come out of their masters seeing the value. Like Matilda, I think it took a while for her to appreciate what we were working towards, but you can tell from her presentation that she owns the work, and because of her line of work, she actually sees the value in what she was doing. Whether some of these things we are doing will result in significant change, I don't know, or perhaps they will end up in shelves, is it? Or in repositories, right? Like somebody was surprised that, oh, Lighton, you're talking about some publication that you authored in 2018. That's 6 years ago, right? And 6 years later, people don't even know that this is a problem, So it's tough out there, but that's okay. I'm not complaining. I don't know if there's another question. I think there was a hand up. Yes, Mr. Stagg.
Good evening, Doc.
Good evening.
Yeah, I'm just curious to try and understand if the institution shares the same vision that you have, if you are receiving any form of support from the institution.
Right. Now, I'll be the first one to tell you that there's an implicit support here because of sometimes I'm very passionate when I'm talking like that, and some people have listened, very influential people. This is how I found myself being a member of the University of Zambia ranking committee, for instance. This is the reason why I found myself working very closely with DRGS, although their interest was just in technical support for the journal platform. But in terms of seriousness, I think you see, when you're high up there, right? If you're looking at people like the DVC Research and Innovation, there are certain targets you have. You will only take somebody seriously if they point at a specific metric that links into what their job description entails. So when I'm talking about this and I mention ranking, important people listen. But in terms of direct support, really, there's virtually no support. We've just taken it upon ourselves. So the prototype tools, for instance, that we've implemented, the goal is that some of these can be integrated within the repository. Some of them, because we have a working relationship with the library, some of these tools, we train the library so that we show them exactly how they can quickly, do their work, right? So, but no direct support here. And in fact, there have been instances where I remember one of the very first proposals I submitted to DRGS through their seed money grant was the idea behind increased visibility, right? And I was shot down. They only gave me money when I presented the enterprise medical imaging project. But yeah, I don't know if I hope I've answered your questions in terms of support. So no direct support.
You have, Doc. Thank you so much.
Now I wanted to draw attention to something else, right? Relative to what we've been discussing. Before we talk about something else, I want to chat about here. If you are following through with Matilda, by the way, because there were a number of people that are not enrolled in CSC 7-1 that were asking questions for this session, we'll direct all the marks to just attendance, not participation, because we were not given an opportunity to ask. But in terms of data collection, right? Matilda went through a very grueling process. In fact, I can even show you some of the data that she was collecting, if you wish, because I have access to the shared drive we were using to compile her work here. Where's Matilda? She's here. She went through a very grueling process of manually compiling these things. I'll give you an example of this. I hope this spreadsheet has this data, right? So it's not like she was getting statistics as in counts. These were actual publications for Lighton. I don't know if I'm here. This is Lamu. Okay, this is Lamu. So for each publisher, each author, each academic member of staff from UNZA, maybe let's look at UNZA so that you see what this lady did, right? She did some tremendous work, some really, really tremendous work. And we are hoping that we can submit this to a top tier venue here. But maybe data matching or data collection, I don't know. I'm wondering if we can find UNZA somewhere here. It was quite intensive and really, I don't know if the examiners actually took notice of the fact that what this person did is tremendous work, really. I hope I can find it here, and then I'll explain so that you understand the crisp DM model we've been talking about here. Maybe things will be a lot clearer then. So for UNZA, for instance, what she did was she compiled statistics for all members of staff. So what you're seeing in the column called author ID here is like the ID for the author, and then you have author name. So if you look for Lighton, I hope I'm here. If I'm not here, I'll be surprised that Matilda didn't do a very good job here. Or maybe is it, I should be here though. I don't know if I'm here. Maybe not. There we go. So if you look at me, right? What she was doing is for each member of staff at UNZA with a profile. This was semi-manual. So the first thing she did, right? The process, if you are following through with what she was saying, she went to Google Scholar, right? And just checked for each institution. Remember there were, 11 of them? For each institution, she would go there and look at how many people from that institution have Google Scholar profiles. For UNZA, for instance, she would go here, right? Search for these people you're seeing here, all of them. And there are a lot of them, by the way. I wish I could showcase a sample of a comprehensive list of all of these researchers. But there are a number of them. So this is paginated. This is page 1 of 10. The way Google Scholar does is I think it showcases, is it 20 or so? Maybe is it 10 researchers, and then you go to the next page. So she extracted close to about 600 out of 900 or so researchers. And for each of them, like let's say you find, let's say Professor Zulu, for instance, here. She'll go to Professor Zulu's profile, right? Get the Google Scholar profile, because there's a unique link to the profile. And then use a tool called Publish or Perish. I don't know how many of you saw that, but there's a tool called Publish or Perish. I don't know if I'll be able to run it from here, but because I've upgraded my software, I'll need to change things here. And get all of these publications. Now, Professor Zulu, for instance, has a lot of publications, right? All of these here. All of these, I don't know how many articles he has here, but 164 of them. So she gets these 164 publications for Professor Zulu, and if we look for Joseph Zulu, we'll be able to find them here, hopefully. I don't know if he's there. Here. Get all of them, right? All the details, like you're getting the author name, the title of the publication, the year, the source, and all the direct link and all that, right? She compiles that, and then what she would then do is she goes to the repository, the UNZA repository, and then she extracts data for all of those 600 stuff, the same publications. So for Joseph Zulu, for instance, if he has content on the repository, she would extract all of them by Joseph Zulu and then do the matching. The way the matching was being done is she figured out a clever way. We had a lot of discussions on how best we could match this, but she created a key that was able to match the things coming from Google Scholar and the things coming from the repository, right? And then you identify which ones are missing ideally, and then she would match them, and then she would compile statistics. So what I'm trying to say here is that if you think about it relative to what we've been discussing, some of the things she was doing could have been automated, right? So automatically extracting these things for each 600 authors. It's a loop, right? For each author, get the profile ID and look up the information using the profile ID. It turns out that if you know Google Scholar doesn't have an API, there are people that have built packages. There are Python packages that you can use to extract this. And in fact, we had co-opted an undergraduate student, Francis, who was doing some of the data collection, and I walked him through how to automate this, and how to do the matching. So it's quite the process here. In terms of the extraction of the data, so the data sources were 2, Google Scholar and the institutional repositories for the 11 higher education institution, HEI high institutional repositories. And then there was the part of merging the data set, because these are 2 separate data sets. And then you figure out the key to use. And then afterwards you do an analysis. For her, there was no, she did not do any fancy like modeling or something, right? She was just interested in pivoting things. I don't know where the final results are here, but I wish I could showcase where exactly she was doing these things here. So yeah, I thought I would mention that because her background is not really classic computing, but she comes from an information science background, and I think she came out of this master's a better person, in my opinion. I've been talking to her and telling her to say if she's thinking of pursuing further studies, she should look at bibliometrics, because then she can build up on the knowledge and skills she has acquired. And she has acquired quite a bit of knowledge and skills, because I remember when you started interacting, she had little knowledge to do with things like pivoting, even formulas, like complex formulas in Excel or Google Sheets, right? But anyways, I don't know if there are any other thoughts or questions about this. This is 1930. I have a question for you. We can proceed and start our discussion of lecture series number 6, or we can have a discussion of lecture series number 6 on Sunday, as per tradition. What say you? Maybe we can vote and just do a yes in the chat, or yes to lecture now, and not, well, I don't know what we're going to do here. Type yes if you want us to have the lecture today instead of Sunday, and no if you want us to have a lecture on Sunday instead. I'm happy either way. I'm happy to do either of the two myself. If you can type in the in-call messages, that would be nice. Or seeing as we are 12 of us, maybe people can just speak to the microphone and let me know what you prefer. Otherwise, the slides are already ready. Actually, I had already, where are they? I had already created the slides. Any thoughts? Or comments on class? I really wanted us to have that that seminar presentation, by the way. It's very, very important that we do. Okay, so Melvin is saying yes, we continue. So we have about an hour left, so I don't know if they're... okay, yes, we continue. Okay, people don't want to lose the momentum. Any other thoughts? Yes. It looks like it's a yes for most of us. But we're going to wait for the others, just so we are not seen to be dictators here. Maybe we can assume that the fact that people are quiet means it's a yes. Okay, we're going to continue then. Thank you very much. All right, so, and Sheila says yes, so I guess it's a yes for most of us. If you remember, what we did last time when we met is we were looking at data preparation relative to the CRISP-DM model, and we mentioned that specifically we're looking at exploratory data analysis, or the EDA process. We walked through some sample notebook. There were a ton of examples. That thing has been shared with you. I hope you've played back the notebook. By the way, I'm still going to insist that we have a continuation on Sunday, because we only have like about an hour to wrap up this class here, right? So my thinking is that maybe we can use part of Sunday to perhaps go through the notebook and go to the next lecture as well. Okay. Yeah. So lecture series number 6 really centered around data transformation techniques. And if you've been following through, you appreciate the fact that the process of transforming the data is rooted in this notion that, for the most part, when you are modeling, when you're working with estimators or so-called algorithms, they normally work with numeric input data. So the data that you are feeding these estimators or algorithms must be in numeric form. So the essence of this lecture is for us to have an appreciation of how we move from text to numbers, how we move from dichotomous attributes, male, female, or FM, to numbers, how we move to categorical data, right? Rich, poor, medium to numbers. So that when we reach the modeling stage, we would know exactly how to prepare the input data. That's the essence of lecture series number 6. Now, colleagues, you see, I wanted to mention something. I got really excited today. I have no idea if you saw this yourselves, but I follow the Ministry of Information and Media in Zambia, and today they announced, right, that apparently, right, government has been preparing through the Ministry of Technology and Science. I don't know why they didn't call this Science and Technology, but the Minister of Technology and Science, Felix Mtati, apparently disclosed, I don't know if it was today or yesterday, there's some event taking place in Livingstone or something, that government has completed drafting an AI strategy document. This is a big thing. It's a huge thing. If I were you here, I would be strategic in what is happening between now and when you're graduating. Because when there's endorsement from government about something, there are opportunities that are presented. There's change coming. That change will require experts. Those experts will primarily come amongst you people doing such courses, right? People that have an understanding, a firm understanding of AI. But in any ways, I thought it would be nice for me to just remind you to be on the lookout. If I were you, I would probably be, following the Ministry of Technology and Science, Facebook page, or perhaps the Ministry of Information and Media Facebook page. All right. So anyway, so the lecture is going to be clustered, organized as follows. We'll just look at the theoretical part first, which is part 1. So techniques and strategies that are used to transform data. And then we shall then start going through a notebook, a walkthrough. So putting the theory into practice, essentially. And that's the outline of part 1, really, right? We'll start with a recap. A reminder here that we're still in phase number 3, data preparation. Yes, exploratory data analysis is sometimes undertaken during data preparation, but there's a lot more that happens during data preparation. Cleaning up, deduplication, right? Pre-processing of data happens in data preparation. But also things like derivation of new attributes from existing attributes, integration or merging of data sets. Classic example is the presentation from Matilda today. She had to merge or integrate a data set coming from Google Scholar and the data set coming from the institutional repositories for the different institutions. Cavendish University, UNZA, University of Lusaka, Lusaka Apex Medical University, the whole 9 yards. There's also issues to do with data formatting and dataset description. But we see also that, for the purposes of lecture series number 6, there is data transformation, right? And in essence, what we are doing with data transformation is for each of the values associated with whatever attributes we're working with, we aim to transform them before we can start modeling. Specifically, what we are saying is that if we look at the example for the student, if we look at this example here that we've been using, the student performance dataset, and I hope it's going to come up here. Please come up. I don't know why it's not coming up, but maybe it was already open. It's here. So for this dataset, I don't know how many of you remember this. When we're talking about data transformation, we are saying that currently the attributes, these 69 attributes, we counted 69 of them, right? Look at count A here, 69. Things like student ID, student name, academic year. These are currently in a form that is not accepted by the estimators or the algorithms. Like if you wanted to use naive Bayes, right? Or nearest neighbor, for instance, or stochastic gradient descent, you cannot use those estimators with the data in its current form. What you must do is you must transform this data. So in other words, is what we are looking at is how do we transform education into a number? How do we transform attributes, these values like religious education, civic education, mathematics into numbers, right? How do we transform yes and no into numbers? That's what we're saying here, okay? And then of course it's a bit of derivation of attributes. But also transformation may entail you transforming numbers, right, into something that is going to be significantly more useful. And usually what you do is you rescale your values. And so we look at scaling, especially when you're looking at unsupervised machine learning really. But anyways, again, just showcasing or highlighting the fact that the data that we work with when we are implementing machine learning models, or let's replace machine learning models here with AI models, for the most part, needs to be transformed in a certain way. Sound would have to be transformed into numbers. Text would have to be transformed into numbers, right? Categorical attributes would have to be transformed into numbers. Images would have to be transformed into numbers. Usually with images, it's just a pixel representation of the image, right? Because an image, like is made up of pixels, right? Each pixel can be represented as numbers, is it? If your pixel or if your image was created using the 3 colors RGB, then each pixel has corresponding numbers associated with red, green, and blue, right? This is computer architecture 101. But anyways, so again, just showcasing here that we are interested in translating these things into numbers. Now, a reminder here that our discussion, our most recent discussions, highlighted the different types of data attributes: nominal, ordinal, interval, and ratio attributes. Right? We had extensive discussions of those things. In some instances, they'll refer to these classical attributes as Stevens' proposed scales, right? Very instrumental in terms of statistics here. See if we can look it up. I don't know if you remember statistics here. Stevens' scales. I don't know if it's scales of measurements, right? I don't know if you remember this from your statistics, but if you don't, as a way of revising the things that we've already discussed, you probably want to look up this, right? So your proposal on how you can categorize the different types of data, ideally, right? These are things we were discussing before anyway. Yeah, dichotomous attributes, interval measures, right? Ratios and all that. But relative to our discussion of AI and machine learning, we see that in addition to those classical scales or types of attributes, there are other types that we should be thinking about, especially in 2024, right? We see a proliferation of certain types of data like text and sound. Everybody wants to send voice notes now, right? People are too lazy to type messages. We just send a voice note. What if we wanted to do an analysis of those voice notes, right? These recordings that we hear about being shared on Facebook about, is it which fashion Sakala speaking to someone from Fars or something? Nobody has time to listen to an hour-long phone conversation, but what we may want to do is analyze that data somehow. Now we are saying that sound does not fall within the classical attributes we discussed. Text, video, and images. One would argue that really video is really the same as images, right? Because your video footage is nothing more than just a series of frames that are made up of images, right? These are images, they're frames, right? It's motion picture, ideally. So again, fundamentally, these estimators that we're going to discuss when we get to phase number 4, which is modeling, tend to work with numbers for the most part as input. They expect numbers. In addition, the result, if it's, let's say, a prediction on what the BNNB value is going to be in October or in November. It's a number. A prediction on whether a student is going to pass or fail. It's not going to be the word fail or pass. It will produce a number. But of course, because human beings understand text better, when you're developing your model, you develop it in such a way that what will come out can be interpreted into a label, right? So you can convert a number into a label. So if it's classifying whether a student is going to pass or fail, you can just say, I'm going to implement a model which will output a 1 or a 0. If it's a 1, if the result is a 1, then a student will fail. If it's a 0, then the student will not fail, right? So numbers as input, numbers as outputs. Now, this process of transformation, in essence, it turns out, involves just the conversion of the things we will introduce as features into numeric equivalents. The word feature is just a fancy term for attribute. Right? A feature is an independent variable that you use as a predictor when you're implementing a model, ideally. Right? And this is contextual. Let's say students at risk of failing. Well, we see that attendance of lectures is a feature. It's something that we know has a correlation with the overall outcome. This is why we had mentioned that at some point, right, during data cleaning or exploratory data analysis, you determine the correlations, the relationships that exist. Part of what you're doing here is you're trying to identify, does this variable have a correlation with the result? Or is there a relationship between these two variables? If they do the same thing, then you dump one, ideally. Feature selection. We'll discuss all these things later on. Now, what we are going to do, right, for this discussion, and this is an introduction here, just giving you an idea or an overview of what transformation is all about. What you will notice from existing literature is that there are other fancier ways of transforming data. But the hope is that the classical approaches we're going to discuss in this lecture will get us to a stage where we can apply these other methods. We also, tend to focus on more common types of data, right? So we rarely look at maybe video or images, or maybe we can throw in images now, I don't know, or sound, right? We tend to focus the classical types in it, but the idea is the same, really. So we will illustrate, how these commonly used data attributes are transformed. So we'll look at examples of nominal attributes, right? So see exactly how we transform the labels in numeric form. Ordinal attributes, if you remember your nominal attributes here, I don't know if you remember this, but this would be, rich, poor, or poverty-stricken or something. How do we convert those numbers? Ordinal, very experienced, not experienced, experienced, reasonably experienced, very experienced. There's a natural order. Those are ordinal attributes. We're going to look at ordinal ratios and text as well. These are the things we're going to use as an example. So we'll start with nominal attributes, right? Now, it turns out that one of the most classic ways of transforming a nominal attribute in its numeric equivalent is the so-called one-hot encoding, right? And the idea behind one-hot encoding here, as the name suggests, is what you're doing is you're really converting the columns, right? Or transposing them in such a way that each derived column is going to be associated with a number, a value, right? A numeric marker to signal whether that particular derived attribute is applicable or not. It's applicable to the observation. Because remember the transposing here, or the one-hot encoding, is being applied to the entire data set. So in this particular case, we have a total of 457 observations. If we are one-hot encoding this attribute accommodation, all of those 457 observations would have to be one-hot encoded, okay? Or at least the values associated with accommodation status, okay? Now, the thing here is usually this is putative, really, it's common, and it works. Usually you'd use binary values, right, to transpose the categorical attributes. So you'd say you'd use a marker like 0, 1, right? So 1 will mean that that particular derived field is applicable, whereas 0 means it's not applicable. And the machine will know. It will know when you show it a lot of those things, because it thrives on patterns, right? Everything is about patterns here. So it turns out really that the combination of these patterns will ultimately determine the category, right, or how you're going to interpret each individual observation. So in the case of these 457 observations, we see that a combination of the patterns, the one-hot encoded patterns, will tell us exactly how to interpret the characteristics of that observation. An example we are giving here, there are two examples we are giving. One of the examples, in fact, both examples are coming from the students at risk of failing data set. In the first case, we are one-hot encoding the minor. If you remember, we said that from SIS, and in fact from the self-reported questionnaire, part of what we get is we get information about the minor program. Is it mathematics? Is it English? Is it civic education, right? Those are examples of, if you remember, nominal attributes, is it? I can go to where we have these things, by the way, so that people remember. You remember this? Minor program. What we are saying is, how do we, what we currently have is we have these things here. These are the different classes we have, right? If these are the different classes we have, we know that we can sort this somehow so that we see the unique entries here. And then let's see if we can fix this here. I'll just do I'll do a flag, and then I'll say 1 here. I'll say 0, and then I'll say if this is equal to that, then put a 1, otherwise it's a 0. So that I'm just trying to use Excel so that I derive just the unique entries for these categorical, for this attribute itself. It's categorical, specifically it's nominal, right? It's not dichotomous, or we don't know if it's not dichotomous, but you'll notice that it is not dichotomous here, right? And then what I'll do here is I will copy and paste this in here as values, and then I'll again add them now as I'll use the flag as the addition, and then I'll add them in ascending order like this. So everything with a 0 here, these are the unique things we have here. This. All right. So the question is, these what's happening here? I hope I don't have to. I hope I don't have to do that. There we go. Thank you. I was afraid that I would have to shut down, do a force restart. So, minor program. There are these 13 labels we have. These are nominal attributes, is it? What we are saying with regards to, and I don't know what happened here. I think my thing just closed unceremoniously. There we go. What we are saying with regards to one-hot encoding is that each of these different attributes are going to be each of these different values. English in this particular case here. ADS, civic education, CLL, these would have to be transformed in a certain way. Now, the way one-hot encoding works is you transform them such that these unique values, the entries themselves, will become columns. So it's like you're coming up with new attributes. And because you're coming up with new attributes, each of these new attributes will have to be associated with an observation. I don't know if this is making sense. But again, maybe if we go back to this thing, maybe it will make sense if we go back to this. Sorry about that. To this. What we're saying is, we have these minor programs, religious education and whatnot. So what we're saying is, each of what you're going to do when you're one-hot encoding this column called minor program is you're going to create 13 new columns. Those 13 new columns must match the unique values associated with the original field. So in this case, minor program. So instead of just having minor program, you're going to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then finally 13. Of course, you do this using, you automate this, right? You'd be using Python or something, and we'll showcase examples in the code. So you one-hot encode it because what you do is you then have these fields here. Now, the idea behind one-hot encoding is when you have these derived fields, you start checking for each of these, and I think this is the part where I think we need to freeze this here. I apologize. Let me see if I can freeze rows and columns. There we go. Bad idea. Let me just, let me freeze them here, not there. So I'll freeze rows and columns here. Christ. This is bad as well. I was thinking that it would work. It's not working the way I want it to work. I want to freeze it whilst here. I don't know why it's not working. I'm going to unfreeze this and then go back here and then just say view freeze row and column. Beautiful. So if you notice here, this is observation number. This is the very first observation. It's associated with the religious studies. When we one-hot encode this, what we're essentially saying is that because this has a value of religious education, the new column called ADS is going to be a 0 because it has nothing to do with ADS. Civic education, 0. CLL, 0. CSE, 0. English, 0. French, 0. Geography, 0. History, 0. LTC, 0. Mathematics, 0. PS, 0. Religious studies, 1. Unclassified, 0. Right? For all the observations. You come to this second observation, record number 3 here. It will have the same values because it also has religious studies. But this third one here in row number 4, it's CSE. Because it's CSE, you go through the same process. Is it ADS? No, it's 0. Civic, 0. 0. CSC, 1. Everything else is 0. 0. 0. 0. 0. 0. 0. 0. 0. Until you come up with a derived, at least values for the derived attributes for all the 457 observations. And the idea here is if you look at row number 4, for instance, you notice like by just looking at the pattern, right? A combination of ADS, civic education will tell you that, oh, the machine will know that it's CSE. In fact, you as a human will know that this is CSE because everything else is different but this column here, right? One-hot encoding. If you look at the other example I have here, the idea is the same, except in the first example, we are one-hot encoding the input variable, the features, the independent variable, the predictor in essence. Whereas in this example, we are one hot encoding the label, the outcome, the dependent variable, and we'll explain these things later on, just now actually. Or is it when you start looking at modeling? But the idea is the same, right? We are converting labels into numbers. In this particular case, we would have, I don't know if this thing has, you know, this is the thing here, colleagues. This thing doesn't have grades, right? So we'd say if, you know, this is the part where if this, right, is equal to, sorry, is less or equal to 0, then this thing is a D plus. Else, if this thing, I don't know why I'm doing this anyway, but assume this was, I think this is a C plus, this is a D plus, doesn't exist, or you say N, not examined. This is a, what the hell is this? This is a D plus, this is a not examined, this is a D, I think, D plus, D, this is 39, this is a C plus, this is a D plus, this is a B plus, I believe. All right, so what we are saying with this example for the labels is, imagine we are building a model which is saying we want to check if the minor, right, if this minor, if the minor positively or results in a more accurate model that tells us whether somebody is going to get an A plus, a B plus, or a C plus. Before we build the model, we have to transform these things like this, input variables. We also have to transform the dependent variable, because when you're training a model using supervised machine learning, you show it examples of things with known results. So what we are saying here is these A plus, B plus, D plus, the whole 9 yard would have to be converted in the same way as this. So what do? We come here and we say grade. Grade has D plus, D, C plus, C, B plus, B, A plus, A, and then for the ones that there's also not examined, for people that have not sat for the exam. So what we're saying is, for us to one hot encode the label, we do the same thing as we did, right? It's called one hot encoding. There's also label encoding, but we'll look at those things and look at examples here. Again, what you are doing in code when you're doing one hot encoding is, it's like a transpose in Excel, right? So you'd come up with something like this. And then again, what you do is in your original data set, you'd create this data set in such a way that it will have extra columns. So if you've been paying attention, you will notice that instead of 169 columns, our new derived data set will have, and we can count them right now, count all. I don't know if you count them all because I've frozen this. But it has 91 columns because we've one hot encode. And in fact, this is why you typically have to look into things like concepts like dimensionality reduction and all that, because once you get to a stage where you are transforming the data set, it can grow in size. Yes, there's a question.
Yes, am I clear that side?
Very clear, yes.
Okay, thank you. I just want to find out a bit behind.
Yeah.
How do you convert it? For instance, the way those subjects are minor programs.
Yes.
There is English, CSE, mathematics, and so on. Yes. So how do you consider to say this one can be 0 and this one can be converted to 1?
Right, right. Great question. By the way, some of these things, when we do the hands-on on Sunday, they'll make a lot more sense actually. But the thing here is that I'm going to assume these are not here. You see, right now, right, our data set has these text values, is it? These are text, strings, if you will. All right? Tokens, words. But we're saying the machine will not work, right? The algorithm will not understand these things. Most of them, anyway. There are some that may understand this. But a good number of them will not understand this. So we need to convert this to numbers. One strategy, a common strategy, is called one-hot encoding. The idea behind one-hot encoding is you're saying you are going to associate numbers to these unique labels or categories. The way you associate numbers to them is you first of all create additional columns. So the dataset currently just has minor program as a column. When we apply one-hot encoding, the first stage is you are creating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 additional columns. Those 13 additional columns are going to be appended to your original data set. This one here. When you create these additional 13 columns, the next step for one-hot encoding is, it's like you're asking yourself, okay, it's a pairwise, it's a pairwise comparison that you're doing here actually. And that's a nice way of thinking about it. It's a pairwise comparison. It's like you are, I hope you are following by the way. Is religious education the same as ADS? If it's the same, it's a 1. If it's not the same, it's a 0. So we can start asking, is religious studies equal to ADS? No, 0. Is religious studies equal to civic education? No, 0. Is religious studies the same as CLL? No, 0. Is religious studies the same as CSE? No, 0. The same as English? No, 0. Same as French? 0. Geography? No, 0. History? No. LTC? 0. Mathematics? 0. PES? 0. But when we come here, is religious studies the same as religious studies? Yes, 1. Is religious studies the same as unclassified? No, 0. Is this making sense?
Very much, Doc. Very
Yes.
much.
Yeah. So this is how one-hot encoding works. And by the way, the funny thing here, colleagues, is that all of this is done in, I want to say, maybe a single line of code or something, right? Well, not a single line of code, but just a few lines of code. But we just want to understand exactly how this thing is done, right? So that this makes sense. All right. Anyways, so that's an example of one-hot encoding. I mean, I know we're going to look at another example just now, but just to mention that we also have gender, right? Gender has 2 values, male and female. When we apply one-hot encoding, we transpose these, male, female. So instead of just having the gender column, we would have 2 additional columns, a column M and a column F. The new derived fields or columns or attributes will be named using the unique values held by the old attribute. The unique values held by gender, at least in Zambia, is M or F. So the new derived fields will be M and F. And then when we're applying one-hot encoding, we would come to our original data set, which is this, and then we look for gender. We can look for gender right now. I'm going to unfreeze this so that we look for gender. I hope gender is somewhere close. Ooh, where is gender? There we go. So you would have, your data set is going to grow in size by 2 for gender. Okay, gender is a good, there's another method I'll showcase here, but if we're using one-hot encoding here, right? You do that, right? The new fields, and we can freeze this here so that it's a lot easier for us to see what's happening. and we froze it at the wrong place, I guess. We can unfreeze this and say we want to freeze it on gender, I guess it's there or something. The new fields, right? Male and female are going to come here. There will be M and F or F and M like this. And then you start doing the same thing. It's a pairwise comparison. You're asking yourself, I'm just going to highlight this so that it's a lot easier for people to follow, right? Is F equal to F? Yes, 1. Is F equal to M? No, 0. Is M equal to F? No, 0. Is M equal to M? Yes, 1, right? It's a pattern. MF 0, MM 1, MF 0, MM 1. You see that there's a pattern, 1 or 0. You've one hot encoded. And ultimately, by the way, the model is going to be implemented by excluding this order or attributes. You're just going to consider the numeric equivalents, but more on that later on, right? So, I mean, in a nutshell, that's the essence of so-called one-hot encoding. Pretty easy, really. Right? So this is what we're talking about, right? And you can see here that there's a pattern. You can clearly see that, oh, if it's an observation that is English, then it will have a one where there's English for the new label, right? So it's just a pattern. But just to mention here, by the way, I don't know if I mentioned this, but when you have a dichotomous attribute, you must think here, in as much as this will work, right? When you have something like this, I'm going to copy this so that this makes sense, by the way. In as much as logically, right, after our discussion of one-hot encoding, this makes sense. But from a computation standpoint, and you have to think about resources, right? Very, very soon we're going to be discussing about evaluation. The fact that when you build these models, right, training requires compute resources. Sometimes it takes time. You can reduce the amount of time. You can increase the efficiency by reducing the size of your vector. So think for a second here. You'll notice that instead of us applying one-hot encoding where we have two derived fields, we can just say we are going to have a new field called gender 2 or called gender machine or something. So that instead of us saying, oh, where there's F, if it's an F, you put a 1, if it's not an F, then you put a 0. You could just say, you decide, F means 0, M means 1. So that the new field now is just going to check, right? If the field is F, if this is equal to F, then put a 0. Otherwise, put a 1. Done. So that the resulting vector now, you won't even have to worry about creating two additional fields. You're just going to create a single derived field, but it's going to be encoded in a certain way, like this. This is also one-hot encoding, but you're encoding the labels direct because they're dichotomous like that. I mean, either approaches work really. What the machine is looking for is a pattern, right? So whether it looks at this or whether it's looking at both of these two is inconsequential really. The idea is the same, right? The pattern is the same. If it sees a 0, it knows that it's a female. If it sees a 1, 0, it knows that it's a female. If it sees a 0, 1, it's male. Anyway, this would be what you want to go for anyway, especially if you are working with a very large data set, if you will. Okay? So, but what about ordinal attributes? Now, you must remember here that in as much as ordinal attributes like experience and wealth, right? Quantiles, wealth quantiles, these are categories, right? I'm rich, I'm poor, I'm comfortable. These are all categories, but they're special types of categories because there's a natural order to those categories. We cannot do what we are doing here to say when we see rich, then it's 1, when we see poor, it's 0. That's not going to fly here. Because, and maybe we should write this down here. Imagine there's a wealth, and then you have wealthy, poor, comfortable. We cannot say we're going to come here and we use one hot encoding and then we're going to say, well, we will transpose this, and where there's wealth we put 1, where there's poor there's 1, where there's wealth is 1, where there's poor is 0, because wealth 1, wealth poor 0, wealth comfortable 0, poor wealth 0, poor 1, poor comfortable 0, comfortable wealth 0, comfortable poor 0, comfortable is a 1. We cannot do this, right? Because there's a meaning to wealth and poor. The scales are different. What you do in this case is you'd have to assign scales, weights, that makes sense. Now, when you're working with Likert-like scale data, those weights, the weightings are defined for you. This is why they will say, I am working with a 5-point Likert scale, meaning that the furthest point to the left is a 1. The furthest point to the right is a 5. 1 to 5 point scale. So you'd use these values 1, 2, 3, 4, 5 as your weights. You can get away with that. I mean, obviously, this is contextual. It depends on the application domain, if you will. In some instances, even though you have the scales already, you'd want to come up with your own weightings, because the machine is only as good as these values that you're coming up with now. So anyway, weights. I'm giving an example here on experience, right? Where we are saying, let's say we are looking at building a model that's going to tell us, oh, you must hire this candidate based on experience. So it will look at the patterns. Out of the 1,000 applicants, right? Part of what we're doing is we're looking at their experience and we're checking. If you have less than 1 year experience, you're given a 1. If you have 1 to 2 years experience, maybe you're given a 3 or something like that, right? This example is different though. So what we're saying is that ordinal attributes and like nominal attributes will have a natural order, right? An implied order, although it's contextual depending on the problem you're solving. So when you're encoding, when you're converting these ordinal attributes into numbers, the ordering must be taken into account, right? In events where you don't have a predefined order, you can come up with an order yourself. Like experience, for instance. You and I know that if you're looking at paying money, somebody who is paid, somebody with no experience may be paid maybe a starting salary of maybe minimum wage, right? 1,500 or something. Somebody who has 1 to 2 years experience, or less than 1 year experience, maybe will be paid a 3,000 kwacha. Somebody with 1 to 2 years experience maybe will be paid. So if you look at this, right? We're saying no experience. Maybe you pay this person 1,500 kwacha. Somebody with experience but less than 1 year, maybe you say we're going to pay this person 3,000 kwacha. Somebody with 1 to 2 years experience, you say, well, we're going to pay this person maybe maybe 6,000 if it's computing. What else is there? Somebody with I don't know if there's something else. Maybe there's more than 5. There's no experience. I don't know if there's more here. But assuming there's 3 to 5, there should be a 3 to 5. Yes. You say if somebody has 3 to 5 years, the starting salary for this person will be maybe 10,000. More than 5 years. We say, well, this person will have maybe a 20,000. Senior dev and junior dev and all that. And this is what happens in real life, really, right? What you begin to notice is that there's a natural order, but the difference between no experience and less than 1 experience is not the same as less than 1 year and 1 to 2 years. So you'd have to take the weightings into account. Now, this is the part where you perhaps involve a domain expert, right? So you have a workshop and you're brainstorming. what sort of weights can we assign? If this is a 1, right? What factor can we give here? And this can be a ratio really, right? If you're following through here, you can do some simple mathematics. You could say if the experience is like this, if you have 1,500, 3,000, 6,000, this is the cheapest trick, right? 10,000, 20,000. If you're creating weights and the first one is a 1 here, what you're saying here is it's a 1 to 5 ratio, is it? It's x here, right? If 1 is equal to 1.5, what is 3,000? Well, 3,000 is equal to this divided by this. If 1 is equal to 1.5, what is 6,000? X, right? So we see that this is equal to this divided by this. If 1 is equal to 1.5 and what is 10,000, right? X. It's direct proportion or something. And you could get away with direct proportion, and you can do the usual things here where you guess you could probably round it off or something to the 0th denominator. You can come here, you do the same thing. It's a pattern. So you see here that, and you can just scale it up here as well. Say round, right? 0 or something. So you see that the weights in this case will be 1, 2, 4, 7, and 13. And not 1, 2, 3, 4, and 5. And this is what you want to do really when you're building the model. So ordinal values ideally are transformed in a different way. You'd come up with weights, right? You'd come up with your own weights. Again, just showcasing here this example where we have different weights, right, for the different ordinal attribute values there. Okay? All right. So next up is, and I don't know if we have a lot of, okay, we can finish here. I think most of these things will make sense when we look at the practical sense here. Next up is text, right? Remember, we're looking at the classic attributes. So in the case of text, one of the simplest ways of one of the simplest ways of converting text to numbers really is the classic bag of weights model, right? You work with term frequencies ideally, you know. So the observations in this case are different. If you remember the examples we're using from here, if you remember the examples we're using from, I don't know where this is here. From here, I think it was. I don't know how much of this you remember when we were pre-processing, right? We realized that, I think I need to unfreeze also. Yeah, I'll need to unfreeze here. Thank you very much. We realized that when we're working with text, like here, maybe we'll go to, okay, that's okay. Survey major motivation. We discovered, right, that when we're working with text, I'm going to copy everything here and move it to a new workbook. I will not transpose this, I'll just copy this. And then I'll order this so that we remove the now entries ideally. I'm just going to order these or sort them. And then go somewhere on top here. So if you remember, we said that when we're working with data like this, oh wow, this is a lot. Support imaging goals and stuff. Okay, so when we're working with data like this observation ID, or we'll call this student ID, one, and then this is +1 or something. Yeah, that's okay. Yeah. And I want to go up to 159 here because our corpus has 159 documents. All right, so when we have this, right, we said that all of these texts here for each observation, these will form your corpus, okay? And for each observation, The text here is called a document. This is what we say. So in essence, for the way the term frequencies or bag of weight model works is that what you do is you get all of these things here. And I wonder how, now you see colleagues, I'm wondering how best to do this here. Okay, maybe we'll assume 2 of them. Smallest ones will be better. Look at these 2. Okay, this is going to work better here if I paste them here. You get your corpus, assuming your corpus has these 2 documents. You get your corpus, and then you identify unique words in the entire corpus. I hope this makes sense here. So assuming your corpus has just these 2 documents, I should hope it will make sense. You come here, I'm going to paste them here. And now I wonder if this is the part where I think there's a split here, is it? Is it? There's no split in the Excel. Now you see, colleagues, this is the part where yours truly will prefer to work with things that he uses often here, right? I want to use Excel because I think it will be a lot easier for people to understand if we are looking at this using something that you're familiar with. So observe, this is a corpus, right? We'll say motivation. And then student ID, 1, 2. What I can do here is I can use split, I guess. It's there in here. And by default, I'll say space. I'll start with a text. This one, split by this empty space like this. And then I'll just copy this formula here and put it here. Now, so the thing is, the idea behind the corpus is that, or behind using a bag of words model is that you, for the entire corpus, you identify the unique words. Okay? Now the unique words in our corpus would be these. I'm going to copy it. I'll call this unique. Okay, I'll call these words. And then I'll just copy them. I'll transpose them also. Transpose. I'll copy them, paste spatial. This is a part where one doesn't really like these things here, right? I'll come back here. I'm going to copy our corpus. I'll create a new, what do you call this? Like this, right? Okay, or what I'll do is I'll copy this and paste it here. You know, I was looking for, this thing is messing up my things. I was looking for paste spatial and transpose like this. So for the first, what do you call this? For the first, I'm going to paste it here. For the first document, these are the unique words in that document. For the second one, these are the unique words. I'm going to paste them here again as values, and then copy them and paste them here. Oops, they have to be transposed. Now, so we're saying in the first document, these are the words. In the other document, these are the words. When you're creating a bag of words model, the columns are going to comprise unique words in your corpus. So it's like you are getting a combination of these, paste them here, get these, paste them here, and then make sure that these are unique. Now these are not unique because guess what? This is the same as this. Sorry, it's the same as this. So they're not unique. right? So the first step is you get all the words, or the first step is you get the unique words and then you transpose them. They'll form your vector. And this is I'm glad I got this. There's an easier way of doing this. So you can get this and say, well, we're going to call this words, and then you say flag or something, and then you paste values only, and then you do the usual. I like doing this myself. If this is equal to actually, before you do this, you have to order these also. By the way, everything works. Everything must be taken into account. You must have camel cased by this stage, right? We're assuming we've pre-processed here, colleagues. So I'm going to sort the range, column as a header, A to Z, like this. So I'm going to say this is 0, and then I'll check if this is equal to this, then it's a 1. Otherwise, it's a 0. And then I'll come all the way up to here and then just paste the formula like this. Formula only. So we see that there's a 1 here, meaning that we can delete this one. Boom. Right? In fact, before we delete this, I'm just going to copy paste this so that they're values because they're still formulas, I suppose. Paste it there. And then I'm going to delete this line because it's the lone one out. So what we're saying is our corpus has these unique words. Because it has these unique words, what we are then saying, colleagues, is that your new derived data set is not just going to have student ID and motivation, but the new columns will be these unique words in your corpus, the terms. So I'll paste them here like this. Oops, transposed. And what you would be then doing is you are getting the frequencies. Now, it's more or less like we're doing something similar, matchmaking, like we were doing with one-hot encoding, the example I was giving. But in this case, you're checking how many always do we have in here, right? It's 1. 1. How many AM do we have in here? 0. How many computers do we have in here? 0. Hard, 1. In, 1. Interest, 1. Interested, 0. Systems, 0. Technology, 1. How many always do we have in the second document? 0. M, 1. Computer, 1. Hard, 0. In, 1. Interest, 0. Interested, 1. Systems, 1. Technology, 0. Now, if you've been following through the pattern, you begin to see here that a combination of these patterns, it would tell you which ways are important. And I do apologize that the example I gave here doesn't have multiple occurrences of a certain word. But imagine we had stemmed interest and interested. You notice that there'll be 1 here or something. Right? So in essence, you're just taking note of the frequency. In some instances, some words will appear often in a document, depending on the length of the document tree. So this is what's called a bag of words model, right? Or term frequencies is what we are looking at here. In the example that I'm going to showcase on Sunday, we shall look at an implementation of Python on how you go about doing this. I'm aware of the fact that people may be tired. This is 2033. I'm going to ask that we continue the discussion of the TF-IDF model when we meet, but the next subsequent slides will revisit this. We'll revisit this notion of a corpus and a document and how to tokenize. I just thought I would give you an idea of what a bag of words model is all about. I'm going to pause here and ask that we stop, but before we part ways, I wanted to find out if people have any questions. All right. Are you still there, by the way? I think so. Yeah.
Yes, no.
I thought I had lost you there. Now, thank you very much, everybody. I will see you on Sunday. I just want to mention something. You see, I am, sometimes I'm attending an event. I'm out of town between the first. I'm out of office between the 3rd and the 7th, and so I would like to let you know that our class next week is going to be virtual, and also to mention that next week we will not have a seminar because we want to at least get to the stage where we're doing model implementation by the time we get to Wednesday, but we shall have maybe a very last seminar after next week. So we have a meeting on Sunday, obviously it's virtual. I'll wait for you to confirm if, Sunday, actually. I imagine it's still going to be 17:30. And then our Wednesday class is going to be virtual because I will be out of town. But I also wanted to remind you that we had mentioned that in the study break period, the week of the 10th, we shall have a test. Now, this is me telling us that the test will be up to lecture series number 6, the one we're covering now, because we'll have finished by Sunday. That's the theoretical test, if you remember. Details on when exactly we write the test will follow through. It would be nice if we could write it on a Wednesday itself, because even if it's study break, but we know that people would have already set aside time, it will be in person, so we'll write it from the computer science department. What that means is that, you see, the test is on the 12th. We'll try and see if we can have the seminar not on the 12th itself, but the test is on the 12th. I don't know if there are any thoughts about the discussion we just had right now, but I'll let you think about this, and I'll see you on Sunday. Thank you very much.